So then, welcome everyone to our session, Implementing an Event Sourcing Strategy on Azure. First of all, before going to the meet, I have to say, and to introduction, a couple of words about the session itself. Back to the times when I was working with a product company, we were building a new warehouse system. And I started to work with the Cosmos DB. It was quite new for me. And with Eldert together, we were discussing quite a lot of different scenarios. We were spending evenings trying to build different architectures and see how it's going to fit, just basically for out of interest. And this scenario with the event sourcing strategy was quite interesting for me because it was a good fit for the product and what I was doing back then, but also the Cosmos DB was a great fit, and we decided to create a session around it just to show everyone how it could be easily used and basically other features of Azure. So, Eldert, maybe you can introduce yourself, a couple of words.
Yes, so first of all, welcome everyone. Thank you for being here. Feel free to turn on your camera, by the way, if you want to. It's always nice to talk to people. But yeah, so I'm Eldert Grootenboer. I come from the Netherlands. I live in Rotterdam, where I work at a company called Motion 10. So with Motion 10, we focus on basically everything Microsoft. But myself, I'm a technology lead and architect. So basically, I'm working both internally and externally with clients, and mostly on Azure and integration. I'm also an Azure MVP, so I also love working with the community. I love sharing knowledge. I love doing these talks. I write a blog. I do a lot of different things with the community, and of course, that's also why I'm here today. If you have any questions, any comments, you can always reach out to me on Twitter. And Olena, a bit about you.
Yeah, just a couple of words. I'm Olena Borzenko. My name started not from the right place, but I'm working in the Decouple group company. It's a global HR solution as a senior software developer. And as well, if you have any questions or comments, I'll be happy to chat. Here is my Twitter tag. And also in the end, there's going to be more details about other sessions. So let's go.
Yeah. So let's take it away. And first of all, we are going to look for a quick look at what is event sourcing. Some of you might have already heard of it, others it might be a new concept. So just a very quick introduction about, okay, what is event sourcing and why do we need this? So event sourcing is about, as the name says, it's about events. So we have different events, and with those events, we can actually get the current status of an entity. So today we are talking about this warehouse system. And of course, with the warehouse system, we're talking about orders. So with orders, you might have an event, an order has been created. They might have another event that says, okay, we added 2 shirts. So there's a new event, a new message coming in saying, okay, we have now added 2 shirts. Can get another event saying, okay, we added 4 hats. And we have another event saying, okay, shipping info was added. And what we can now do by playing back these messages, we can actually see, okay, what is the current status of this entity, of this order. So if we play this back message back, then we will see that, okay, there was an order created, it has 2 shirts in it, 4 hats in it, and it has some shipping info. And now any client can just basically play back these events and see, okay, what is the current status of this specific order, of this specific entity. So why should we use event sourcing? Because I think most people here, if not everyone, at some point created or worked with a CRUD application. So we create an order in our database. We have different different providers reading from this. Some of them might be updating this. There might be some deletions. And this is okay as long as we are not in a very write-heavy environment. If you have a lot of different consumers and producers, we might run into some troubles here. So for example, if you have a lot of different producers that are all trying to update this data and or all working with the same entity, we start to see that we are locking our data, because that's the way we work with the database. If someone is working with that row, we are going to lock that row, because of course we cannot have 2 producers writing in the same entity at the same time. And this locking of data is something that is really good for a database, of course, but maybe not something that you always want, because it means that if you have lots of producers, they will have to wait for each other, and you might get into some deadlocks or timeouts or something like that. So CRUD is not really easily scalable. So with CRUD, we run into the issue that, okay, it's okay if we have like tens, hundreds, maybe even thousands of producers. But as soon as we are coming into like millions of producers, like really high throughput, right heavy workloads, we see that CRUD is just not scalable enough for what our needs are. Because concurrency in this case is really difficult. It's very difficult to say, okay, we have different producers, they're all going to write to the same entities, all to the same rows, all to the same objects. Because we get into the locking issues, but also we get into issues like, okay, one of them is going to read the data, it's going to update this data, it's going to write a new state, but in the meantime, someone else might have read this. And you get in those concurrency issues like, okay, I have many different providers, many different consumers. How do we know that our data is actually in the way that we expect it to be? And finally, one more thing about CRUD is there's no history. We cannot really see, okay, who changed what, at which point, what was the previous data, unless, of course, we build our own audit store. And that's like, of course, we can build our own audit store, but it's another thing that we have to introduce. We have to, once again, look into the locking of data, looking at concurrency. So it's not something that we cannot do with CRUD, but it makes life much more difficult. And this is where event sourcing comes in. Because event sourcing basically helps us solve all these different issues that you have with CRUD. So the event sourcing pattern is all about insertions instead of updates. So we don't only insert objects, we only insert events. So we have a data store, and this data store only receives events and inserts them. We don't have a database where we are going to a specific object and update this. Instead, we just have all these events that we can play back. And this is perfect for those write-heavy workloads, because this allows us to actually have multiple, like big amounts of consumers, big amount of producers, all writing to that same data store. And then whenever a consumer needs this, and we will see it later on, where we can work with projections, like CQRS kind of style. Basically, what the consumers are going to do is just read back all those different events and just say, okay, so this is the current status, and then they can update this on their own software. And inserts are, of course, much more efficient, because I don't first have to get the current state, update that state, make sure the data is locked, make sure no one else can update it. Insert is just, okay, here's my message, insert it. This is what I want to do. And that is what event sourcing is all about. Just like, okay, I did this, I want you to do this specific resource, please do this for me. And of course, because you have these events, you already have a built-in audit log. Because we can exactly see who sent what event at what time. So we can exactly see what object in which state it was at a specific time, just by playing back those events up to that point. So this all comes out of the box with event sourcing.
Eldert, I do have a question. Can you please tell us a bit about scalability? Before in the previous slide, there was easily scalable. Yep. And what about event sourcing? How easy it is to scale it?
Event sourcing is very scalable as long as our data source can handle this, and we have a look at that in the next slide. But as long as our data store can handle those inserts, then we can just scale up indefinitely. Because inserts are very easy, like we don't have to log things, we don't have to care about concurrency, we just have to make sure we can handle our inserts. And we are going to look at how we can do this on Azure, of course, because there are some different components that will come into play here. Because of course, once you have the pattern for this, like we have a very scalable pattern, we also need to write services for this, because not any service can just handle this scale. So let's have a look at how we can implement event sourcing on Azure and which services we are going to use for this. Because this is really important. Event sourcing is really about that high scalability. Of course, you can also do it like in low scalability scenarios, like it's not that you can just do this in high scalability, but it's really made for that high scalability. So we really have to think about, okay, which services can actually handle that scalability. And actually, Olena, can you talk a bit about cost of review and how this works?
Sure, of course. So yeah, actually you already said that basically scaling depends on if our data store can handle it. And that's true. That's why exactly what we decided to go with Cosmos DB to try it, because Cosmos DB is globally distributed and massively scalable multimodal database like store. So beside this, Cosmos DB has a great feature. We will have a look into it a bit later, but it's called change feed. And this change feed can save for us all the events which are happening, all the changes which are happening, all the documents will be saved there. And regardless of our wishes, like this history will remain there like until the end, like until you would not remove the document itself. And this is basically event sourcing out of the box. Whatever's happening in your system, it's all saved, and you can access the change feed, pull the data, or maybe subscribe on the change feed when those events are going to be pushed to you. And that was a great fit for us in this case.
Yes, indeed. When we talk about event sources like Cosmos DB is the perfect data store for this. But once you have the data store, we still have some other components that we actually need because our events are coming from somewhere. And we don't want to expose our Cosmos DB directly to our producers. So what we are going to do, we are going to put some and what we are going to put in front is Event Hubs. There we go. And Event Hubs is once again about the scalability. So Event Hubs, as the name kind of suggests, is also about processing events. It's about processing streams of events. So if you have many different events coming in, but they are belonging to the same kind of process, so in our case, the order process, for example, these can all be streamed into there, and then we can play them back, and we can push them out to different, like for example, to Cosmos DB. And what is really nice about Event Hubs is it's very high throughput. It can handle millions of messages per second. And once again, we are talking about high scalability. Event Hubs is perfect for this. Of course, there's different other options that we could have a look at, but I think Event Hubs, especially when you talk about like high scalability, Event Hubs is the place to go. So definitely have a look at that. And what's actually quite nice about Event Hubs is that it has some other protocols that it can handle as well. For example, you can actually handle the Kafka protocol. And I'll talk a bit about more than that later on, but what you can actually do is have a Kafka application, change the connection string, and stream it into Event Hubs, and then have all the nice things of a PaaS service, like the maintainability, you don't really have to think about what is running on. All that in Azure while still running your existing applications. However, of course, when going through from Event Hubs to Cosmos DB, we need to have something there as well, because we cannot just directly connect this. So Olena, can you talk a bit about functions?
Of course. Yes, so we can basically, using Azure functions, we can connect to our Cosmos DB to change feed, for example. Azure function has built-in triggers. So we can use those triggers to subscribe on a specific container and react on all the changes which are happening. Either it's update of the document, or it's a read, or it's a creation of the document. So with this, we can, first of all, be very responsive on all the changes, but also Azure functions are serverless. They as well, like managed by Azure, but also easily scalable. So for us, again, that's a perfect fit. We take in this brick, connecting to the Cosmos DB, and then we can do whatever we want, either create materialized views, build out of it some functionality, maybe transfer data in another data store, basically control the data flow and application as we want.
Exactly. So basically with these three components, we have everything to build our high scalable event sourcing application. And that's actually what we are going to do right now. So we are going to show you a demo where we actually have a Kafka application. Like I said, Event Hubs can actually handle the Kafka protocol. So we have an existing Kafka application, and we are just going to connect this to Event Hubs. So our application, in this case, will be our order system, our warehouse system. We did, of course, a demo. We have just one application where we're doing this. Normally in the real world, this would be like many different applications, many different systems, where orders are coming in, where the processing is being handled, inventory is being checked. In this case, in the demo, we just have one single system that will do all of this. But that system is going to send different events for different transitions of the order, basically. And those are going to push into Event Hubs because, like I said, you want to have something in between where you can actually stream the data in. We can play it back if we need to. We can process it. We can transform it. And then finally, we have a function that will actually trigger on this stream of data and actually going to maybe do some transformations. In this case, we are not going to, but we could do some transformations. In this case, we're just going to gather data from the stream and push it into our Cosmos DB. So our function is going to trigger whenever new messages are available to us. It's going to spin up one or multiple functions, depending on how many messages are available. And it's going to transfer those messages into Cosmos DB. So let's have a look what this looks like. So first of all, let's grab that Kafka application. I have my Kafka application over here. As you can see, it's just a simple application. I'm not going to run through all the code. The code is available on GitHub. So if you want to actually check all the code, then you can do that there. I'm just going to quickly run through, okay, what are we going to do here? So first of all, we are going to use the Kafka library. So we just use the Kafka library. So as you can see, this is just default Kafka, nothing special. I don't have to change anything for Event Hubs. I can just use our default Kafka library, and I can then connect that to our Event Hubs over here. So in my connection string, I just have my connection string from Event Hubs, and this will just send the data there. So we're going to create a producer, and this producer is going to process an order, or actually multiple orders. So let's say we are going to create 1,000 different orders. Now, actually, let's start this so this can run in the background while I'll talk to this code. And this is just going to create all these tasks to process the order. And what this will do is the process order is just my simulation of our complete warehouse environment. So it's going to create an order. As you can see, it's all random data. So we can actually have different customers with different orders. And this order is going to go to some different states. So of course, first order will be created. The order has been requested. So someone placed an order to the website, to an app, or something like that. So we're going to create different orders, and then we are going to update these orders. We are going to add some articles. So different orders will have different articles. And then we are going to submit this. And this will be for every state, like that's what we are going to do. So next up, we are going to accept the order after a certain amount of time. We might update some articles. So some orders might get some updated articles. The order might be canceled. So we have some canceled orders in there. The order might be picked. The order is going out for delivery. And finally, the order will be delivered. And so we have different orders in different states at some point. And by playing back all these different events, because these are all events that are being sent to our Event Hub, by playing those events back, finally our consumers can see, okay, this order is currently being picked, this order has been delivered, this order was canceled, and they can just see, okay, what was in the order and who was the customer and something like that. So as you can see, these orders are all being sent, and these are being sent to my Event Hubs. So if I go to my Azure environment over here, I have my Event Hubs over here. And if I refresh this, let's see if we can already see some messages coming through. It might take a while because this logging is lagging a bit, so we don't see it yet. But well, if we go back over to our customer DB later on, we actually will see that we have data in there. Like I said, this kind of logging lags a bit, like it can take a couple of minutes to actually get some data in there. But what happens? So we are sending those events to our Event Hubs, and we then have a function over here, and this function, as you can see, is being triggered. This function will actually get the data from Event Hubs. So it sees, hey, there's new data in my Event Hubs queue. It will get the data, it will start processing it, and will send this out to customer DB. Let's have a look at the code of this function. I have my Event Hubs processor over here. And what's really nice is I don't actually need to know how does Event Hubs work, how does the SDK work. Because I'm using functions, I can actually just say, I want to have an Event Hub trigger. And this trigger has some different parameters. So I have to say, okay, what is the stream I'm looking on, and what is my connection string? And that's all I need to know about connecting to Event Hubs. So I don't need to know about checkpointing. I don't need to know about how the messages being, how do we deserialize messages or anything like that. I just get an array with events, and I can loop through that array. And if I have many different if I am sending in a lot of messages, this will actually spin up multiple functions, and each of those functions will have a certain amount of data in there. So what I'm going to do then is I'm going to create a Cosmos client, and this one actually I want to show you because over here I'm using this Event Hub trigger. This is really nice because it abstracts away all the logic. I could do the same for my custom DB. I could actually have a custom DB output binding. However, with bindings, you don't have as much control as you have with SDK. And in here, I actually want to ignore all the null values because my schema actually has, I'm using the same schema for all my different events. And in my schema, I just want to say, okay, if there's not any data in there, I want you to ignore the null value. And that's not something you can do on the binding. So instead, I'm using the SDK. And once again, this is a nice thing about functions. Like I can use those bindings that abstract everything away from me. But I can also just say, well, instead of using a binding, I'm just going to use the SDK itself to have a bit more control. So in this case, I'm going to connect to my custom DB. I'm going to make sure that container exists. And then I'm just going to loop to all those different events that are coming in from Event Hubs. I'm going to get the message body, so I'm just going to get the data from there. I'm deserializing this as an order. And then once again, I'm going to ignore some different things. And then I'm going to just observe this item. And of course, we will never have an update. It will always be an insert. So we're just going to push all those events into my Cosmos DB. Now, if I have any exceptions, I will handle those. But this is the important part. Like I'm running to these events. I'm pushing them out into my Cosmos DB, and that's it. So if you now switch over to my Cosmos DB over here, I should see that I have some orders in here. As you can see, I already have some orders in here. Let's just refresh this. And when I look into these orders, I will see that I have different orders and different statuses. So for example, I have an order here for this customer. It's been requested. There's some different articles in there. So they're ordering some different articles. As you can see, I've already quite a few different orders in here. So of course, the first ones will always be requested because I first request 1,000 orders and then I'm going to update them. So what I'm actually going to do is get an order that has already been through this previously and just see, okay, what are the different events that came for this order. So I got this specific order over here, this order number. And if I look over here, I see that I have some different events for this. So I have a requested event where it says, okay, it was requested, is order number, this customer, these are the articles. It was then accepted. And as you can see, there's different information here. So it's the hub ID. And the hub ID will later on be the warehouse where we're actually going to pick this from. But this one, for example, just updates status accepted. This one is picking. So I now have a picking start time that I can retrieve from this. At some point, it went out with delivery. And finally, it was delivered. And by playing back these 5 different events, any consumer can now see, okay, this order has these different articles in it. It was for this customer. It went out to delivery. It finally was delivered. We can see different times. And so this allows us to actually play back those different events and just see, okay, what's the end state of this specific order? And of course, different producers can send in different events and they will all just come in this log and we can just play back the log and see, okay, what is the status of this? So we have now seen how we can actually create those events, how we can send them out to Event Hubs, how our function will pick them up, will maybe transform them, and finally push them into our custom DB. And from there, we can actually start working with those events. Now, next up, I'm going to actually pass our presentation over to Olena. And then she can share her screen and she will continue this and talk a bit more about materialized views.
Yep. Thanks a lot. You should be able to see my screen just if you can. Yep, cool. Great. So my part, we're going to talk about materialized view. So basically, we already saw that we can write some data in Cosmos DB. What going to happen next? So why do we need to use materialized views? How to do this? And in general, we will have a look into implementation as well. So in a traditional way, normally when I have data in my store, data store, database, doesn't matter, I would write a query, and every time when I need to fetch this data, I will call this query, and basically that's how I do this normally. But with the Cosmos DB, that's not exactly the case. If you would execute query every time when we need to fetch some data, it will just end up in increasing our cost, increasing consumption of request units, like for memory, and we will end up just complaining the Cosmos DB is just too expensive. So what we can do to optimize basically our querying operation for make it in more efficient manner, we can basically pre-calculate, pre-populate, pre-save our views. So the queries which we will execute, which we will normally call on every fetch of data, we will pre-calculate them and we will store them somewhere, maybe in a separate container, maybe in a separate database. But this data will be ready for us to fetch, and we would have no need to execute it again on the fly. And of course, we will react on every change which is happening in our container. So whatever document, a new document arrived, or maybe a document got changed, with the change feed, we will react on those changes using Azure functions. And we will update our pre-calculated views. So we will also always be sure that whatever is happening in our system, our state is always will be up to date and current. So yeah, Cosmos DB change feed is gonna be a great help for us in this case, and I want to say a couple of words about how it actually works. As we can see, our application can communicate to our database, and what is happening basically under the hood. When we wrote our data in a container, so in our case, it's a container with orders, order documents. Change feed will store all the information about our actions, like document got created, then document was updated, one order got added, or maybe customer changed this information, maybe some more articles were added to the to our order. All this information is going to be saved in change feed. So what we can do in this case, we can interact with the change feed. So we can pull all the data from the change feed. So there's 3 ways basically how to do this. We can, first way is pull all the information from the change feed, either from the very beginning when our database was created, or from the certain point in time. We can extract those events and basically replaying them, either create materialized views or like basically aggregate our data. And as we see on the screen, we can have overview for the customer, how many orders he had, or maybe overview for the warehouse, how many orders were fulfilled today, and etc. etc. So we can create those views, we can pre-save them somewhere in a different place. But this, when we are pulling this data, it's basically the most complex way how to interact with the change feed, because everything has to be handled. We have to specify which partition we're going to access and handle all the exceptions. Basically, everything, the full management is on us. However, this could be a great way to interact with it if we need to have one-time data transfer. So if we want to go away from Cosmos DB and use another data store, we can connect the change feed, pull everything, save it, and be done. But I would not maintain that kind of approach if I need to do this on a regular basis, because this is another like potential source of problems. A second way is to implement change feed processor using change feed processor library, basically an abstraction on top of change feed, where we can specify which container we want to listen to, we want to subscribe on, and every time when there is a change, when the change will happen, we will receive those events. They're going to be pushed to us, and we can do exactly the same, what we had did before, create materialized view, maybe transfer the data somewhere. It's just much easier way if we need to interact with change feed on a regular basis. But of course, we're going to use Azure function because this is the easiest way. It's a serverless, small piece of, small brick of like business logic, basically. Azure is going to manage everything for us. I just need to say which database, connection string, and the container name I want to be subscribed on. And then again, all the changes, everything that's happening in change feed going to be pushed to us as the events. So that's basically the structure, how a server works under the hood. So what is happening when we are writing data to Cosmos DB? There is the whole ecosystem, which is like basically handling our actions and our data. Let's.
So, Olena, before we go ahead, I do have a question.
Good.
So, yeah, so you're talking about we are going to create different views of our data. We are going to replicate our data. Now, when I was in school, and this was back when we were still using Borland and stuff like that, so things have probably changed, but I was always thought like we are going to normalize our data, we are going to make sure we never duplicate our data. Ivan, now you are basically saying we are going to duplicate all our data for different views. So can you elaborate a little bit about, okay, what has changed that we can now are going to duplicate our data instead of normalize it?
What has changed? Of course, I mean, I'm still amazed from the school you was which school you
Way back.
attended. Yeah. Yes, that's exactly what I said. We going to duplicate our data. So we have one storage, we have Azure Cosmos DB, we have change feed for every container, and then we're going to depends on the changes. Actually, what we want to do, we're going to either duplicate it or aggregate it and pre-save those pre-calculated views. Why do we need to do this? Because as I said before, like when we have relational database, like I don't know, typical MSSQL database, we have all the data in one place and we can just write a query and fetch this data anytime we want. With the Cosmos DB, that's not the case because they use partition strategy, and basically the physical servers, they are globally distributed, and they guarantee the data from one of your containers, like the logical partition, the whole logical partition group of documents will be always stored in the same physical machine. However, it doesn't mean that your whole database will be always in the same place, in the same region. So it means if you have really a lot of data, querying this data would mean not only like cross-partition querying, but also sometimes you will need to access different servers, and it will not just be slow, it will be super slow, but also it will be very, very, very expensive. And it's fine if you need to do this like call this query only one time per month, then it's fine. But if you have to do this every day or like really like every minute, yeah, you will need to really invest a lot in Cosmos DB. So that's why you need to duplicate your data. It's the best. It's kind of the best practice and recommended approach. Storage of data, 1 GB of data costs like 50 cents or something like this. So basically, you can duplicate as much as you want, so as close to the user as possible, and in an aggregated way for all your consumers as they wanted. Because you have single source of truth and you just transform your data and expose it in the way how they want to have it.
Awesome, thank you.
Good. So we stopped at the point when we wrote data in the Cosmos DB. And what we're going to do now, we're going to have a look on the Azure function, which is going to listen to the specific container. In our case, it's order container. With this Azure function, we will implement creation of materialized views. We're going to have only one Azure function just for demo purposes, but normally I would go with 2 independent functions for scalability, of course, and to basically make the development process easier for the team, and then in general. Then we will pre-save our materialized views in the Azure Cosmos DB, and of course they're going to be it's going to be easily accessible for our clients and consumers. Oops, let's go to the code. Yeah. So there is our Azure function. As we can see, I'm using Cosmos DB trigger, and as I mentioned before, I just need to specify the connection string, connection name, database, and database name. This collection name and flag, if you want to create it or not, basically it needed to share the state of between the Azure functions of the change feeds. So once we specify the connection string and database name and which collection we are listening to, we will be able to receive those updates in this case, read-only list of documents. This is going to be our input, and we can interact with this event. So I will skip for now those 2 lines. What's going to happen here? We will just iterate through the documents which we will receive, and we will log some data, maybe not, depends on our needs. And then we will deserialize the document in an order object and create those materialized views. So basically create and save them in a back to Cosmos DB. I'm using as well Cosmos client as Eldert used before in his example. I'm doing this just for demo purposes. What I can do, I can also use output binding like this. So I will not need to use Cosmos client. I can just say, okay, I have Cosmos DB output binding. I will have a dynamic type here, but I can also specify that this will be a collection of my documents, like to automatically deserialize it. I think it should be possible. So we have out of our documents, and here I also have to specify which connection string, collection name, and database. So where I want to write my data after I will finish execution of Azure function. But just to have a look how it could be done with the Cosmos client as well, I decided to go only with trigger in this case. So we have two objects which are customer overview repository and hub overview repository. There's not much of a logic in there. They are just basically a creation of containers. In this case, we have customer overview container, which will store Materialized views for our customers. So basically how many orders and what articles were ordered by this customer. And then the second repository, it's hub monitoring, basically for our warehouses to display on the dashboards how many orders incoming in the system for today, for example. We will save this information in this container. But the main logic, basically, what we're going to do is in base repository. Again, you can also access the source code in our GitHub repository and to have a look in more details. But just to briefly explain what is happening here, we have three methods to access document, create document, and update document when we need it. I will read the document using point read. So it means that I know exactly which logical partition I want to tackle and which exactly document I want to access, because I'm going to use ID of the customer or ID of the customer as a partition key. And I know that this ID is always unique, so I can use it as a partition key and as a document ID. This will just simplify the way how I'm going to read my documents. For the creation and update of the document, quite similar here. Of course, for the demo purposes, it cannot be more complicated. But what is interesting here, first I'm setting flag enable content response and write to false. It means after I will execute my request, after my data will be written in Cosmos DB, I would not receive back a response of what was created or what was changed. So I'll just say, I'll just have okay, like 200 or not. And I'm also providing a partition key. It's not required. I can just remove it and it will also work fine because we're using SDK. But it's just a small improvement to basically performance improvements. So SDK would not extract it under the hood, but it will be explicitly provided. And for the updates, it's basically looks exactly the same except the method we are calling. And going back to our triggers, so we have those two repositories. They will allow us to interact with Cosmos DB. And as I said before, we will just iterate through our documents and we will create Materialized views and save them to a database. So for the customer, as I said, I'm going to use customer ID. The logic is pretty simple. I will just have a look if I already have this aggregated view saved in a database or not. If I don't have it, then I will just create a new one. If I already have it, I will update existing one. For the warehouse, in general, logic is the same. The interesting thing is that I'm going to use here synthetic partition key. I'm going to combine warehouse ID, which I'm using like to store my documents as well, with the datetime. So this will make it. This will make my basically partition key unique for every day for every warehouse, and will allow me as well to have a point read of the document for every day, and I can be sure that it's going to be only one document per day, which makes it unique and safe for me to read this document. The same operation here. I'm getting the document. If I don't have it, I'm creating one. If I have it, I'm just updating which is exist. So yeah, that's basically it, how Azure Function looks like. And again, I would normally move this functionality in a separate Azure Function, and I'll keep one Azure Function for creating a customer overview and a separate Azure Function for the warehouse overview. Let's have a look then, go to our portal and see how it actually looks in the database. So we have our Cosmos DB. We already, when Eldert ran his part of the demo, because the database was created with the containers inside, and here we already saw this part, our document with the audio information. But also, as you can see, the customer overview and hub monitoring container was also created, because my Azure function, when Eldert was running his part of the demo, Azure function was already published on Azure. So here for hub monitoring, if I will select the items, we will see, as I mentioned before, for the ID of the document and the partition key, I'm using the same value, and this is basically warehouse ID combined with today's date. And here I have the summary of the orders. It's basically just order numbers and a count. So every time when in my warehouse with ID like 10,000, gonna be new order will be created there or updated. This count number will change, and of course, like numbers on the dashboard or whatever will also be updated. That's how the warehouse, the hub monitoring like overview looks like. And if we'll go to the customer overview, here is the same situation. We have a ID of a document and customer ID, which is partition key in our case, which is partition key path. They are the same. And as we can see here, we have a count of orders and we have order details for every customer. So basically, if we have in our web application or maybe one web application page where customer wants to see the order overview, all the history of his orders, this would be a great example of how to use this materialized view. Basically, that's it for the materialized view. Materialized views part, and let's go back to our presentation. And we are almost done with the presentation. Before we will finish, just a couple of key takeaways. Yep. And so we already had a look how we can use Cosmos DB as a central append-only persistent data store. We also had a look how we can use change feed in our case to react on all these changes, and basically how we can use event sourcing with Cosmos DB. Also,
yes, so event sourcing on Azure is amazing, because when you have those write-heavy loads, this is where Azure shines. And not just Azure, of course, like we are talking about Azure today, but every cloud has their own capabilities for this. But I really think that thanks to the cloud, we can do these kind of event sourcing patterns where we can have millions of producers and consumers that are all connected to these different systems, because we now have the different services that can actually handle this load without us having to buy like big data centers or stuff like that. We can just get that capacity, use it when needed, and scale down again when needed as well. So when you are looking at these heavy write loads, actually do have a look at event sourcing pattern. Of course, we have to see it here today. There's also different information out there, among other things, on the Microsoft documentation about how to set this up and how we can implement this.
Yeah, that's great. And also we had a look how we can prepare materialized use. When you were talking like about your like first demo part, I think you mentioned something like a CQRS approach, and actually, yeah, that's materialized views. That's exactly what you said. So we will have our write operations separately from read operations. So we will basically prepare our system to be easily accessible for read operations. And in the same time, under the hood, we will perform our write operations, our updates. So they're going to be separately, and we will have these separations between the queries and basically comments execution. And Also, materialized views, as we saw already, we can recreate and duplicate data as much as we want, but the great thing is that it's going to be from the single source of truth. So we can be sure that our state is always current, always the same, and that our data is also not corrupted somehow. And the last point.
Yeah, so, and of course, today we have seen three different services. We have seen constant B, we have seen functions, we have seen event hubs. But Azure has much more out there. Azure has a lot of different services that we can all combine and that we can use together to actually create more powerful solutions. So what I would say is have a look at what is out there on Azure. There is at the moment 280 services or something like that. Maybe even more if you count all the sub-services as well, but there's a load of different services out there. So really have a look at your scenario, which pattern fits that, and how Azure can actually help you solve those solutions.
Great. Yes, I remember that you also told me this many times to have a look at different Azure features, and that's exactly the case. Even with Cosmos DB, we can have some connectors under the hood to Apache Spark if we need to have some real-time aggregations, what I found quite great because for the warehouse system, for example, that was exactly what we were looking into. But yeah, for now, it's we are done. Here is again our details for the LinkedIn or Twitter. Feel free to connect and leave us comments or questions if you have any. And I do believe that there's some.
Yeah. So I also want to like to say thank you, Olena, because it was amazing to be on stage with you again, even if it's virtually. Hopefully next time we can do this in person in Sydney because I'm really missing Sydney.
Oh, we will soon in a couple of days.
Exactly. No, not in Sydney. That will be Barcelona. That's different.
Yeah, that's true. That's true. I hope
Yeah,
next time.
and to everyone that was here today, also thank you for being here. I hope that you are enjoying NDC Sydney. NDC is actually one of my favorite events. So enjoy the rest of the session today. And indeed, there are already some questions out there. So let's have a look. If you have any more questions, feel free to put them into the chat, either here or on Slack, or contact us on our Twitter. So let's start with Glove. So there seems to be multiple points of potential failure. Before an event gets to the single source of truth, event source in the Cosmic DB, we go through Kafka, event hubs, functions, and finally event source to act on from application perspective. There seems to be suggest multiple points of compensation required if one message fails but other related ones get through. Any thoughts on this and how you can tackle it? So yeah, basically the question here is, okay, we have different points where things can fail. And what do we do if one of these points fail, but we have multiple different events that might be working with the same entity? And this indeed is a very interesting question. And I'm an architect, so my answer is always, it depends. So
Very
first
political
of all,
answer.
yeah, first of all, event sourcing is not the single solution for every issue. Let's put that first. So what we have shown today is working with a specific scenario. And I would actually say that event sourcing, if you need like pure transactional processes, you can do it with event sourcing, but it will be harder. So maybe look also into different options there. Like, for example, Service Bus has much more function around transactionality and rollbacks and things like that. However, of course, you can do it in event sourcing as well with the different components we show you today. You have to think about, okay, what happens if one of those components fails? What do I need to compensate? Sometimes it might just be like, okay, we'll just accept that maybe one of those entities might not be in a perfect state. For example, on Facebook, if one of my messages don't come through, okay, it's not great, but no one is going to really care about it. That one of my messages might not have come through, or might come through later, like 5 minutes later or something like that. So that is one option that you just say, okay, we just don't really care about it. If something goes wrong, our data is not that important that this will break something. On the other hand, if you're talking about especially like financial data or something like that, you definitely have to think about compensation. So if you're working with financial data, stock transactions, things like that, really have to look, okay, what are the different points where we can fail? And maybe indeed implement some kind of compensation logic around this, where you can say, okay, if this part fails, then we might have to actually get all the events for this, maybe flag it for someone to actually look into this. Maybe we are okay with, okay, if this event comes in later, then we will just pause, like lock this one until it has been caught up. So there's different options. And like I said, I'm an architect, so it all depends on your scenario. So there's not one size fits all. That's definitely something to think about at the start of your design. Okay, if something goes wrong, what does this mean?
Well, that's a great answer. Having said that, I think that I can read the next question, which is much smaller, and then you can read the next one, which is much bigger. Sorry, but so how do you handle multiple updates to the same entity at once? Question from Aaron. Well, in Cosmos DB, in Azure Cosmos DB, they have a functionality of conflict resolution. So basically, you can set some rules that automatically, for example, the latest change will be picked, or you can have a kind of like journal of your exceptions, like of errors, and then you can go and manually decide, maybe programmatically, but decide how to handle those conflicts. And yeah, basically that's what's related to Cosmos DB, but what is related to your logic, I guess, it depends on how you will implement the functionality itself. But it's not that big of a problem. So of course, if there is a like concurrency, maybe there could be some complications, but in general, Cosmos DB has this functionality of conflict resolution.
Perfect. And so I think this will be the final question so far. If you have more questions, actually, no, there's a new one after that as well, so we'll handle that as well. First, let's start with this one. So consider a scenario where you have multiple types of events incoming, like order created, item added to order canceled, etc. How to manage ordering when replaying these events at a later time. If the three events types are on three separate topics, so one for the created, one for the item added, and one for the order canceled, there's a good chance that the order canceled will already be processed before all the order item added events are processed. This could cause items added to fail because the materialized order is already canceled when trying to update this. Yeah, so this is indeed a thing that, once again, you really have to think about, okay, especially when you're playing back later on. So if you play back later, you have to think about, do I start playing back in a specific order of my different topics, for example? So if, for example, if I have an order cancel event, I know that this should always be the last event I got, for example. Then I know, okay, I'm first going to, for example, read my order created topic, get all the orders created. Then I'm going to read all the order added, and then I'm going to read all the order canceled. So that might be one solution. Another solution might be something like actually just as soon as you get an order canceled event, then you say, okay, this order has now been locked. You can still add to the document, but we are not going to do this anymore. In the front end, we'll just show this as canceled, even though there's still playback happening in the back end for the order item added. So once again, different ways to handle this, different options to handle this. And also, of course, once again, depends on your scenario, what makes sense for you. But there's definitely some guidance around this on the internet as well. Also, just because this is not specific Azure, like there's a lot of guidance around event sourcing. For example, Greg Young has written a lot about this. So definitely, if you want to know more about event sourcing, look up Greg Young, and he will like explain a lot of different details about this as well. About how you can indeed handle this kind of scenarios.
Yeah, that's true. I can talk about it for a really long time. The next question we have is the Kafka support dynamic topic creation. Does the service follow over the event hubs as well? Question from CN.
Yeah, so I'm not quite sure. I don't think so that we have dynamic topic creation already. But like I said, I'm not completely sure. I don't work that much with Kafka. I've done it a few times with different customers, but I'm not very deep into this. So I know that it's there in Kafka. I have not used it myself for Event Hubs. But I would definitely say to have a look at the documentation side of Event Hubs, because there's a complete list of all the feature parity for Kafka. I know they want to be completely feature parity at some point. I don't know where they are yet. So I cannot answer this question right away, but I definitely would say have a look at documentation for Event Hubs, and there's a whole overview. Okay, what parity do we have at the moment?
Cool. And there was another question. If you will share the code samples to Slack, yes, we will. We will send the link to source code. And the other one, what if there is inconsistency between source code of truth, the source of truth, and materialized view? How do we troubleshoot, find such inconsistency? Well, first of all, we will need to understand why do we have this inconsistency. I can imagine this scenario if we went to the materialized view and edited it manually, or we allowed other maybe parts of the system, maybe another, maybe some Azure functions, I don't know, whatever, like your system also like went and then edited materialized view, which should not happen because your materialized view is just a snapshot of like your aggregated data, and it should not be changed. If you want to change your materialized view, there are some events should be replayed, and yeah, some events should happen, and they should be updated not by just changing the state of the view, but actually something happen in the system. But if you have this inconsistency, you can do kind of like smoke testing with Cosmos DB, so you can identify from which point of view you started to have the problems. So you can replay from the very beginning, or at some point of in the change feed, you can replay the oldest events and see from what exactly moment you started to have the problems. If you replayed everything a couple of times and there is no problems, but your data is still inconsistent, then there is definitely somewhere some outer basically factor which is changing or updating your data. Something went wrong, and maybe in your business logic, maybe if you have some dependencies in your code during creation of materialized views on other part of the system, maybe those pieces like gave a failure. But normally you can replay and see if your state is changing of the materialized view. If it's changing, you can identify from which point of view it happened, and then find the problem. Is it a problem with the data, or it's a problem in your dependencies, or it's a problem in the business logic itself? But yeah, basically replaying change feed, that's good already quite a lot. It gives you a lot of flexibility of how to find the problem. And yeah, that was the last question, I guess.
Yeah. So once again, thank you everyone. Thank you, Olena, for a great session. Thank you to the NDC crew for being our host and having us here today. And I already saw Jas coming by, so I was looking at the session. Looks very interesting, so definitely people can stay around for that as well. And enjoy the rest of the conference.
If that would not be a night, maybe I would also sit and watch something. Yeah, thanks a lot again. Thanks for the great questions. Thanks for the nice welcoming hosts, and really it was a pleasure to be here. Thanks, Eldert, for sharing the stage, for being an amazing co-speaker. And yeah, enjoy the rest of the conference, everyone.